A capacitor is a simple device, and unusually, the electrical symbol you see here closely matches what it really is. To try and show you how it works and what it does, we'll start by making one. I'm using 2 thin sheets of plastic. This is a laminating pouch, but any 2 thin sheets would do. I'm covering the gap between the 2 sheets with a sheet of aluminium foil and just smoothing that out. A contact wire is going to be put against this foil. Spraying adhesive on the outside so the second sheet of foil doesn't slip. I'll stick that on securely. A large sheet like this is not very convenient in an electrical circuit, so to make it a better shape, I'll roll it up. And that also allows me to put in a second contact on the second sheet of aluminium foil. And so there we have the finished product. To show what it does, I shall put it in a simple circuit with a meter and a battery. Although I won't bother with a switch, I'll just use the clip to contact. As I do that, there's a pulse of electricity shown on the meter. Going across and touching the other side, shorting out the battery, there's a pulse in the opposite direction. You can see the change in sign on the meter. On first touch there's a minus sign, and as I move the clip over, there is no minus sign, it's positive. Well, as demonstrations go, that's singularly unexciting, but actually it's quite important. Let's examine it more closely. Within the atoms of the metal foils and wires, the nuclei contain protons which have strong positive charge, and these are surrounded by a cloud of mobile electrons. In total, all the charges cancel out. So let's examine what happens when we close the switch. When we do that, we complete the circuit so that the battery is connected to the capacitor plates. The battery pulls electrons from one plate and pushes them towards the other. This is the current flow that was recorded on the ammeter. So that one plate has a surplus of electrons and the other a surplus of positive charge. In reality, this would happen in a tiny fraction of a second. The next thing I demonstrated was shorting out the battery, removing it from the circuit. If we do that, then there is a simple circuit with a surplus of electrons on one side and a deficit on the other, and they naturally enough flow back until the balance of charge is in equilibrium. So, what is it that the capacitor does? Well, it stores a small amount of charge and hence a small amount of electrical energy, often for only a tiny fraction of a second. But this role is crucial, as you can see, by noting the large number of capacitors that can be found in most complex circuits. Thank you for watching.